FM is brought to you by Synadia, the stewards of the NATS project.
Hey folks, welcome to Season 3, Episode 1 of NATS FM, and you've got three of us for this brand new season, and you're going to be saying, but hey Dave, what happened to Season 2? And it's a great question. Anyway, so onwards with Season 3. No, let's not do that. So Season 2, we came out of the gates in the new year, energized from RethinkCon, and we did one episode, and then we did no more. And we've had new things happening, right? So we've had office hours going on. So we had Jeremy, which then transitioned to Nate. And then we had a load of feedback saying, hey, bring NATS FM back, because when you guys lose the plot and you start talking about random stuff, we miss that and we love that. And can you go back to basics, give us some real world builder stories, and just give us something to listen to whilst we're walking the dog and driving home. And that's what we're here to do. And that's great, right? Because with my face, it's great for audio. You don't need to be watching this stuff on YouTube. And for this first episode then of Season 3, we've got two amazing guests. I want to say guests, but really the kind of like fabric of NATS now. I'm going to start, sorry Tomasz, I'm going to start with Maurice. Obviously Maurice has been in the community for a while now. He's, on the NATS side, on the maintenance side. So hi Maurice, you've gone from ambassador to working with NATS full time with the kind of core team. So welcome to the NATS FM podcast, officially welcomed obviously to Synadia on the NATS side.
Yeah, for sure. Quite the transition, I guess.
It's an awesome transition, and obviously then we have somebody who you shouldn't be too what's the word I'm looking for here? Unrecognizable voice-wise, and with his crazy curly hair. For those obviously who are just listening to this, not watching, we got Tomasz as well from the from the core team and previous host. So I guess this is kind of how we mean to go on, right? The core team are back, so you got myself, we've got Tomasz, and we'll also have Nate from Office Hours joining us from the core host team, and then we're going to bring guests along as well for different topics, starting with this one. And we're going to start with all the fun, and start with core NATS, and why we might want to do that, and what we can build, and what does it mean to be, running a basic style infrastructure for your applications. But before we get into that, this podcast is brought to you by Synadia. We are officially the stewards of the NATS IO project, so welcome again to Season 3. So let's get into it. Core NATS. Which one of you wants to go first then? Let's talk about core NATS. What is core NATS? When we talk about core NATS, what are we talking about?
That's a good question, because I think that with all the layers we added on top of NATS, getting back to the very basics, being core NATS, is really important, because I think it's really NATS used to be super simple, meaning very simple API with just core NATS. And then with addition of JetStream objects or key value and all of those things, it grew a lot. And sometimes people don't know where to start, or they even skip core NATS entirely and go straight to JetStream, for example, because, we need persistence, so let's just start there. But the important, and that's one of my most beloved things about NATS, is that it's so built like on layers, on the core NATS. And I think that if you understand core NATS, you maybe you don't know the internals or the details of everything above it, but if you understand core NATS, you will be fine with JetStream objects or key value and whatever other abstractions we built up on top of it, including the service API. That's a great thing to get back in, to start Season 3 from this. I think that everybody who starts with NATS should just try to understand. I think if there's anything you should try to understand, it's core NATS. Because if you get this, then everything else, it no longer feels like it's magic. It just feels like some complexity, some state, some consensus, and a bunch of other stuff. But I know the principle of the protocol that operates and allows me to do those things, which makes it so much easier for so many things. So yeah, let's talk about the core NATS. And I think that's the best thing. I don't know, Maurice, if you agree. Is just everything is PubSub.
Yeah, it's actually funny that you started off with like people using first JetStream and then going back to core NATS because I was that guy, so to say. So I first like 2 years ago started with JetStream, and also kind of did the same path of going back and kind of needing a request reply pattern where I needed multiple people to respond. And the initial thought was like, okay, let's just use because everything was running in Kubernetes, of course. um, it can just be a HTTP request. I'm going to send 2 requests, and I'll get two answers. Sometimes I only need 1 answer, so I only send 1 request. But of course, you already imagine like that doesn't scale well if you need to have multiple responders. And this was also interesting where the responders were kind of different services. So you can imagine that the one it was the same request, but one service would answer pretty much model A and the other would model B, and with kind of different data types. So just and in the end, it's so obvious. Just publish one message and let multiple people respond with NAT score, and it's
Yeah.
like, yeah.
It's interesting, isn't it? 'Cause I think most conversations start with, but I need reliability. I need to know the messages are being sent. And it's like PubSub all the way down. Request reply, well, it's PubSub, but with a reply inbox. It's PubSub, I think unicast PubSub, whatever you want to call it. But if I want to go I want to crank the basics and make a point of the basics because it's so powerful. And once the concepts sink in, from this point onwards, it's like somebody's, opened the curtains and shone a torch in your face and blown your retinas out. It's the truth is kind of like, retinally painful. So if we start then, the most simplest NAT system that you could possibly ever have. This is one for debate. This is probably going to cause outrage in the community, but a single NATS server. So just started off with no authentication, just NAT server, go, with 2 clients. Now you could even do 2 NATS clients at this point. So on your machine, you could have like a 3-split terminal. You could start the NAT server and you could have 2 NATS clients, and one you could do a sub, or one you could do a pub. And at that point, you've exercised the most fundamental, basic thing about NATS. And with that pattern alone, you can, I don't know what. I did some early bench tests on my Mac M1, and I think I was getting ridiculous numbers like 48 gigabits per second or something crazy. It was insane. But something makes me laugh. And this is going to, Tomasz, you're probably going to laugh at this, but Maurice, this is going to be a tester. So if we say, when you initially connect, NATS gives you a dial tone. This is Derek showing his age a little bit, but I'm similar age-ish, so I can appreciate what dial tone is. Maurice, do you remember the days of dial tone?
I don't dare to answer again.
Okay. So I'll embarrass myself, right? So back in the days when everything was black and white, when we hadn't discovered colour, colour yet, you'd pick up the phone, and the first thing you'd hear is to be like a horrible 45 hertz, 50 hertz noise in your ear, and that was a voltage coming from the local phone switching place. And then I had a rotary phone as a kid, so and it'd take you 35 minutes to dial a number to have a conversation for 2 minutes. It was crazy. But the dial tone, you pick it up and it was like the phone's connected. It wasn't connected to anything other than the network, but I've got dial tone. So the whole thing of NATS is once you connect up, it's like your system has dial tone at that point. And once you have dial tone, the semantics of what you can do change, because then suddenly you have some, I don't want to call it reliability, but you have some delivery means on the NATS system, right? So if we have 2 clients connected to a server and we connect and do nothing, we've got dial tone. And then let's say we want to do some PubSub. We publish a message to Foo that says hello, and we subscribe. And providing we've got the subscription open and then randomly send publishes on the subscribe side, we get messages. So let's talk about that bit first. And I want to talk about the perception of reliability within that domain.
Yeah, I get your analogy, Ed.
It's Derek's, to be fair. I mean, I'm just repeating his. I don't want to carbon date myself either, but yeah.
I immediately jump into how the dial tone compares to our protocol actually. Technically, is it correct? But yeah, it's just for an explanation. It's a really nice analogy, I think. Yeah, I think that this is by our, I mean every engineer that everything we do, we try to raise the reliability to the possible maximum. Whatever we do with databases, we try to raise the best possible guarantees, no matter the performance, no matter we need them or not. The same happens with NATS, and it's at most once. No, I need guarantees, and it's for my whole career I've seen this over and over that you need this, you need those guarantees. Where in reality you rarely need all of those, and core NATS, even without any persistence, can give you quite some guarantees if you think about just purely like a way to communicate between things. But it's surprisingly how much you can do with just core NATS and just communicating over the unreliable network, meaning not almost any network. And as you mentioned, right, the PubSub, this can be pretty unreliable, but with the request response or any abstractions built on top of a PubSub, because request response is also PubSub with some protocol specifics, you can get a lot of reliability out of it, because you can know if somebody get it or not. And actually NATS helps you with this, telling you if in request response pattern, if somebody got if there's anybody listening to your request, which solves a huge category of problems, like timeout happened, no idea what it means. In NATS, if everything is functional in terms of network and infrastructure, you very quickly get an answer that nobody is there, maybe the service is down or something like this. So there are so many ways you can get some guarantee of what's happening in a system if the recipient get the messages, etc., without introducing pretty heavyweight persistence layer, because every persistence layer is pretty heavy. It just stores everything if you use JetStream, while here you can be way more selective on what's stored and what not. And I think that we all are part of the thinking, the mindset that we need as high persistence as possible out of the door, and we never think about it.
But we do, because that's what we're doing now. We're trying to reset some of those controls. So Tomasz was, he mentioned the whole thing about request reply, request response. Obviously, we've got PubSub, and I think that splits. It makes an interesting divide down the middle. We've got what could be considered unary, so one system trying to communicate with another directly. So then you'll get things like error no responders. Something's not listening. Or you can set a timeout and say, actually, I'm going to do a request and then wait. And if obviously I don't get one, I can time out and then handle that elsewhere. So there's some great mechanisms on the request reply side, massively scalable. And then on the right-hand side of that divide line, then you run into the kind of more opaque versions, I guess, with PubSub. So, Maurice, I'm going to pick on you a little bit, right? So it's a little bit of sport hunting, but I'm not going to be cruel. So let's talk PubSub, right? So if you were going to build something with core NATS and you wanted to obviously embrace the PubSub pattern, I'm going to ask you two questions, right? How would you handle reliability from a publisher, right? So you're publishing data into NATS and your application needs to know that something is being done, either from the app to NATS and then app to elsewhere. So I'll start with that one first, and then I'll ask question 2 in a mo. To put you on the spot, you can do this.
I'm sweating. No, so I think in general, not even specific to NATS, like just with any network or process, at least my own opinion is you should assume anything could fail, regardless if you're using NATS or not. So if I want to have permission reliability, if someone received it, I must always expect a response back, like, hey, I'm knocking on David's door, and he actually needs to open and say that he actually gets my envelope or whatever kind of example. But regardless if it's NATS or not, you need to have that's push. You have a forward flow of your own information. You actually need to get acknowledgement or confirmation that you got it. And if you don't get that, you need this kind of retry pattern. So they're maybe you're going to say I'm wrong with that, but I don't believe there's any system where you can just send a message only once and it just works, and you can always guarantee that the message is received. I mean, I don't think that's possible. You always need to retry and hopefully be prepared for the worst cases. Although like 99% of the time it's not an issue, but yeah. So simply put, just sending a request out, getting a reply from an app saying like, "Hey, I've got it," and then I could continue on like normal. Probably send a new request, and otherwise I need a strategy in terms of timeouts of retrying, and it also depends on kind of the use case and what makes sense.
So I'm going to take one step back from that, and I'm going to summarize what you just said there. It's app design, it's architecture. So if I'm publishing into the ether, let's say if I'm publishing first and foremost, I can assume that I'm connected up, else the NATS client should say, actually, you've got no connection, error, something or other, not connected, whatever. But just publishing into the ether, once I'm connected, and I'm thinking about IoT use cases here, like some of those machines will just have data, just get rid of it, get it away from me as fast as possible. And some of those things don't need to know that anybody's listening because they don't care. If I'm a temperature sensor and I'm just going to broadcast every half second what the temperature is, do I care that anybody's listening? My purpose in life is to measure the temperature and tell anybody that's willing to listen what the temperature is. But obviously that's a very narrow use case, right? So I want to keep this within core NATS, because anybody who's going to be driving now is going to be saying, Dave, you moron, just use JS Publish and get your quality. I'm like, no, we're not doing that. We're talking core NATS. So it changes the design. So if you're publishing, I don't know, you might want a response back every 10 seconds to say, here's an aggregate, or here's the last thing that we received, or whatever, just to kind of give your app a signal that everything is fine and everything's happy. Or you switch to request reply, where you can get some signaling semantics in there. I know it was a bit of a hard question, Maurice. I'm not trying to be awkward, I promise. I like exploring what we can do with the most simplest building blocks, and I think publish is a really, really powerful one. Obviously, you can publish very, very fast as well. But if we flip this now, the second part to that, when you're a subscriber, and I think the answer is pretty much going to be the same, but as you're a subscriber to the system, now, application designer, are you expecting to receive things, or is it sporadic? That's going to change your design. But from a subscriber point of view, again, let's talk about reliability and how to engineer for that with core NATS. Any takers?
Yeah, I think that we have all the answers actually in the JetStream, right? Because if you know about it, JetStream is actually built on top of core NATS. It's just using publish, subscribe, request, reply, and that's all it is. So even the Raft layer is built on top of core NATS, sending heartbeats. So you can ask like every 10 seconds, let me know you're alive. Yeah, Raft is in very much simplified terms. It's just this. It's just making sure that everybody are listening. I mean, at least the quorum is listening. And when you talk about letting me know once in a while if there are still people there publishing, and we are now getting another subscriber, in pool consumers you have heartbeats, and those are well thought through processes that try to provide guarantees for every user. But in your specific use case, you might not need all of those guarantees and all of those patterns applied, just a tiny bit of them. Like, just, I don't care about any kind of the quorum, just once in 10 seconds, just let me know. So I think that JetStream is a great place to talk about how you can achieve reliability with core NATS, right, Maurice?
Yeah, for sure. I was also thinking this like if like what's when using JetStream, and of course it's about core NATS, but I'll get to that bit. So I was really amazed at, if you have a replicated stream, just how I could literally like try to actually break the system and restarting servers and try to block things, and the system would just work. And then you realize this is built all on core NATS. So, and it cannot be that JetStream is just magically more performant or like better. It's like built on this initial layer. So inherently, with that statement, it must mean that apparently it's reliable, right? So they're given the right patterns, you get this guarantee of reliability, and of course also shown in JetStream, of course.
Yeah, and in many cases, I think you can actually achieve reliability needed for your purposes, like temperature checks, right? Like some sensor sending some info. you don't need the whole overhead of JetStream for the quorum and stuff like this, because all you need to make sure is that the sensors are there, that they give you just some kind of liveness probe, some pinging and stuff like this. And by the way, we're all actually thinking about some even abstractions layers that we could provide to users, how to do those things in simpler ways using core NATS. Because as said before, the JetStream try to do it the best for every user in a way that will allow you to even pass, I don't know, card transactions or whatever is extremely important to not lose anything, and to have it replicated, etc., etc. Where for so many use cases you absolutely don't need it. And you can get obviously so much more performance out of core NATS, because as you mentioned right at the beginning, you can get like 10 million messages per second if you try very hard on single client, a little bit less on subscriber side, but like this never real world scenario when you need this much as at one client side. But it's impossible to achieve the same numbers in any fully persistent layer like JetStream, because it's just no disk or no IO layer will provide you this ability to do this and replicate it, right? So core NATS is extremely powerful because you can build JetStream out of it. I used to say that JetStream is just core NATS with server subscribing to your messages to store them.
Because it is.
Because it is. Because it actually is subscribing to your messages. But in so many cases, I always would love to tell to our users, just please try to start with core NATS. And at the moment you start to feeling that you're reinventing the wheel of consensus, of persistence that has to be, when you want persistence that needs to be replicated, or you want to persist everything you send, then yeah, probably JetStream. But other than that, it's like you said, David, once in 10 seconds, just let me know you're alive. But if you're like less important data, let's once in a minute, let me know if you're alive. Once in hour, check we have data. There are so many patterns you can apply yourself, which are dependent on your setup, that you can use to get so great performance out of it. And the best thing is that you're not like deciding core NATS or JetStream. I'll make a small tangent, but that we are good at those, so I'll just excuse myself. Because the beauty of NATS of being like everything is PubSub, right? Request reply is PubSub with reply subject. JetStream is request reply, which is PubSub. Key value is JetStream, which is again PubSub at the end. Everything we do is PubSub. And you think about it, that means that whatever, you don't have to lock in yourself into like JetStream or core NATS or service API. You can start with core NATS and then expand into JetStream for what you need, not for everything, because it's much harder to say, okay, I need more reliability or persistence for this, but not for that. It's much easier to just start adding this than do everything for JetStream and then say, okay, when I can resign from the guarantees. It's somehow mentally very like, it's like throwing things away from your house, like, oh, I will need it one day. I feel it's like this. And because everything is PubSub under the hood, it feels that you don't have to worry about which API from NATS or abstractions on top of NATS we are using. You can simply start with core NATS, then go to services if you like the abstraction, because services work seamlessly with core NATS because it is core NATS. And you can really often mix and match JetStream with core NATS in many ways. So it's not like you have to start with JetStream if one of your system needs persistence, so I'll immediately start with JetStream. No, just start with core NATS, add JetStream when you need it, add key value when you need it. And that's, I think, that the advice I would give actually is that the beauty of NATS of everything being PubSub actually means that everything is PubSub, and that you can mix and match those things really nicely without, having any kind of the fear of missing out. Oh, I will not have this guarantee or not. No, that's fine. You can add that to whatever system you need.
And there's also very little pain in migrating. So with like like other system, also other system. I'm mostly thinking about HTTP, where you kind of build in this pattern of I'm going to send a request within the sensor updates, and I don't need a response, but I'm going to get the response, so to say. So just because of how things are decoupled in that way, you can actually have this app that's just publishing the sensor updates, and later on you can just seamlessly switch to those subjects being captured by JetStream, and the app doesn't even need to know. That's like I think the magic as well. And
So it doesn't need to, though, does it? I'm going to jump right in there because you've said a couple of things I'm going to now use to get on to the next bit of the conversation. So the HTTP semantic, and I love this at Byron. He coined the term the HTTP developer. I think it was on one of the episodes. I don't know what episode it was, but it had me in stitches, and I've never forgot. So the HTTP developer was coined on one of these episodes. And when we think about building APIs, dare I say it, using HTTP transport, most people think about these things in just two ways. One of them is get, give me the stuff, go get. So you make a request. If the system doesn't respond, what happens? Well, you might get a timeout, you might get a 404, you might get a 500 if there's a problem. I don't know. But if it's not there anyway, whatever. You might even get a TCP socket open. But most people understand that you make a successful request. What happens? There's a wireline transport. There's a literal get that's sent out, and then you get a response that comes back with headers and everything else. And if we just look at that and then compare it to NATS, and we go, all right, well then we have request response semantics on there. If there's nothing listening, the NATS substrate itself will tell you there's no listeners, error, no responders, go away, nothing's there. That's very useful for reliability thoughts. And then you can add timeouts and stuff, go get, and if it times out within a second or whatever, well actually that's bad now, go, my app can make a different decision. But then you've got retry logic on top. You can add your own retry logic, but then how many of the clients have got their retry logic embedded? So can you add in options to the clients to get them to retry things?
Yeah, this is interesting topic you just touched, because you touched on a thing that we thought were simple in the past, and now we do think that it are the opposite, because adding a retry is adding an opinion to the client. It means we think that it should work like this. It should retry 3 times. And if you're building a web app, something simple where you want easy way to get your messages, and if something goes wrong, it will handle your stuff automatically, then it's great if it retries 3 times and there's high probability that you get the response without any action in code. But if you're building transactional system when your card transactions have like 5 seconds to complete, or it will be handled offline, or whatever the banking system, how it works, then you want immediate response that something went wrong, please tell me, should we retry? And we had some opinions, and on some opinions we stand firmly that they are good, because we said that clients will automatically handle reconnections, because NATS works in a very different environments where network is the probably weakest in the whole system. And if clients would handle, users would have to handle manually every connection lost and stuff like this, resubscribe to every subscription, etc., that would be a really bad experience if your client is running in the vehicle, for example, because it will lose connection all the time. So our clients do reconnect automatically and resubscribe to the subjects that they were subscribed before the connection was lost. But they will give users the feedback that disconnect happens and that the reconnection will happen and was successful. And you can tweak it, but it's different than saying retry, because here to make it nice and at the same time not induce your opinions on how it should behave for the users, it would have to mean that your retry for every failed attempt will signal the user somehow that something went wrong, which is totally not a pattern you see in the wild at all. Usually you specify the number of retries and last error or something like this that is returned. Because otherwise you have two kinds of callbacks or some channels, or depending on the language. a different mechanism, which would not help at all, I believe. So that's our challenge for quite some time right now. What to do with those? Because for 90% of like use cases, yeah, it should retry, but it will then make very bad user experience for those 10%. And you cannot say ignore the 10% because it's always different kind of 10% for every feature you imagine. So suddenly it's like whatever you do, it's opinionated. Somebody will come and say, yes, this is bad. So what we, go on, Maurice.
Sorry to kind of interrupt you right there. So I think it's very, I've seen this also, it can be very dangerous to kind of enforce a single opinion as a whole. So it might sound very logical, like something can fail, it's logical that you might retry. But I've seen projects where this was like stacked. So the front end would send a request to a backend, and if it failed, it would retry. The backend, the front end didn't know, but the backend made a call to another backend, and that's also did retries. And based on timing, like it would bring the whole system down. So it's all you cannot have one. Like from one use case and one perspective, it can be very valuable to have a retry, but having that opinion is set in stone like that, it is really hard to not break the system in a way if your use pattern doesn't align with that. So it's just that was such a horrible.
Yeah, and it actually gets worse because then we have contributors who are coming in to our project, to the clients, and say, hey guys, in Java world, this would be great to have in because every Java client in the wild have this and this feature. And we're like, yeah, but we try to keep parity across the clients. And this feature makes zero sense in like Rust or Go because, we try that each client in our ecosystem is idiomatic to the language, but at the same time follows some resemblance across the clients. So you can you can switch between the clients and feel like at home, moving from Rust to Go to Java to .NET, which is pretty challenging because there's always some kind of the balance. But actually, less opinions you have, the easier it becomes. More opinions you add, it's suddenly, because opinions sometimes are use case based, sometimes they are language specific based. So we are fighting this. This contradicting interests of I want this utility, I want our users, or it's either contributor or ourselves. Oh, it would be so great to add this, but then it creates a a domino effect that now every client needs to have it, and sometimes it makes very little sense or no sense, and it also explodes the client scope. So after some time, we came up with this idea to start to switch the focus and the client to focus on reliability, basically low-level NATS protocol binding in each language with JetStream, etc., and core NATS, and very basic unopinionated patterns and use cases. Almost no use cases, just patterns and bindings. And then to create a separately versioned libraries elsewhere, extensions to the clients, where we could not only improve of the APIs, because our listeners who are using things like Object Store may say like, oh, I would like to add Object Store is great, but it's missing this or this bit. And we're like, yeah, we agree, but it would mean a breaking change. And if you make a breaking change, you suddenly have to break every client in the major version release because of one part of the API changed. If you want to be honest with Semver, and we really try to be honest there. So we are stuck with this API which couldn't improve because we don't want to break any of our users, and there's no much room to improve on that. So this is another reason. So we started putting those extensions, how do we call them, extensions, opinionated functionalities, new abstractions layers, experimental APIs to a umbrella project called Orbit, where we just when we see a new PR to the client or somebody, when we chat across maintainers, say, oh, this would be great, but if it's only one language, or this would be great, but it feels it has so many opinions put on top of it. You feel, yeah, but so many people need it, but it still does not fit the client because it's so opinionated. we made a home for those things, and they are starting to land in orbit. And so we did a segue from core NATS.
I'm going to pin you there.
Yeah.
That's going to be episode 2. So you've described the segue and the on-ramp beautifully. I want to stop you right there before you get into orbit, because I can see your brain going, orbit.
Yeah.
And there's nothing wrong with that, but it's an episode 2. So, sorry, listeners, if you're kind of going, don't stop him, just tune back into episode 2. There you go. There's the hook for the next one. I'm not going to do this. If you like this, click subscribe. No, just listen to episode 2 and you'll get all the orbit goodness.
But
they'll come back.
I
They're like
admit the
lemmings.
tangent could be longer than the whole podcast, so
Yeah.
I admit it. Yes. You're right, David, here.
Right. Back to core. No, you made a beautiful segue, and I love the way that you describe it. Like, the idiomatic nature of the clients is important, but obviously the familiarity across the clients for the concepts of NATS is really important as well. I mean, I get that it's a very hard balance. I think orbit makes a lot of sense. Tune into episode 2 for more on orbit. Now, connections. So engineering and managing reliability, and I know I'm being very grey around some of the terms, so reliability can be at the connection level, it can be at the semantic level, it can be at the data durability level, but what I'm really talking about here is squeezing the juice out of core NATS, and we can't do that now without moving sideways into the topic of connections. And I see this come up all the time. Somebody who's been familiar with databases will go, how do I pull NATS connections? And you go, okay. You can't just say it depends. So I'm going to build something with core NATS. I'm going to create me a connection, and I'm just going to spew some random questions, and either one of you can pick this up. But I'm going to do 3 or 4 publishes on the same connections, and I'm also going to do 3 or 4 subscribes. So let's go top down. Number 1, is that a good idea? Number 2, how does it work from a sharing perspective? And will I see delays and latencies across those actions if I'm sharing the connection? And when is it a good idea to have dedicated connections per thing? So let's go through the top ones. And I'm sure you can remember those questions just fine, by the way.
Yeah, I'll just briefly start, and Maurice can chip in immediately. I think that for like the starting point, we are used to the pooling of connections. Very used to, especially in database world. It's so frequent question to the community on the community to the clients. Where is the pooling? But again, getting back to like why you should start with core NATS and then think if you need more. It's the same for the connections. You should start with one connection, and unless you are something very specific use case, you should keep that one connection, and it should be enough for everything you do, assuming that you have some kind of a system of either microservices or some kind of distributed systems. It's just not one application and the other application and nothing in between. Usually it's more, and you can put a lot of stress on this one connection. Like you can have, we did a really hard effort, and we are still continuing on it, to remove the head of line blocking problems in NATS, meaning that, yeah, it is coming over TCP, obviously, but we try our best to make it in a way that unless something really fishy is happening over the network, it should really not affect you. And if there's something wrong happening over the network, there's pretty high probability that it will not affect only this one TCP connection. So I don't want to say that's always you need one connection. There are use cases for more than one, but I would always start with one. Always. Maurice?
Yeah, no, I agree. So I think also an important thing to highlight there is that with one connection, you also preserve publish ordering, and the answer there is kind of, again, it depends, but anyway, but there is also this benefit to if you have multiple publishers, for example, within your same application, but using one connection, it also means that they preserve their ordering. And also that means that people subscribing either within the same application or maybe also in a different application, they also see the same ordering. And maybe there might be some messages interleaved with other applications, but like the ordering of that single application will be preserved. And also kind of going back to the publishing benchmarks of core NATS, you can stress one connection very far. It's Wow. So there, and so I think it's I agree there with you should try to stress one connection as far as you can go. Like you don't need a new connection for a new, for example, don't talk in JetStream. You don't need a new connection for a consumer, then also a new one for a publisher, and then you maybe have 5 streams, so you have no times two, times five, it's so to say. You can all do that over one connection. And pretty much my when would you use multiple? The answer that I would give to that is only if you're running into this issues. So there might be, for example, that also might depend on the clients. For example, in the Java client, there are some triggers to do with queue sizes. So we then needed to make a decision like, hey, we have one publisher that uses just way too much throughput and fits neatly within that queue and how it's implemented in that language. So we need a new connection for some other bits which are not related, but just with that consideration in mind. Not like the connection cannot handle it, more like with the single publisher we can actually get more guarantees, but also depending on like the internal implementation and having looked at that and actually needing that. But not necessarily by default.
Yeah, I think that the only use cases is like when you have a very specific network setup that somehow can, work differently for different connections. We have some customers who have, very specific network setups over the cloud providers, which they need them. But for them, it actually makes an improvement to have more connections. But the good thing is that it works pretty fine, right? You can just create 2 client instances and it will work fine. We don't provide pooling because I feel that if we give pooling to the users, everybody would start with pooled connections and half of the people will be confused, like why I lost the order of publish
and they
messages.
Wouldn't even know, would they, why they're doing pooling. It's just because that's what they did somewhere else. And this is why I wanted to jump on this really hard, actually. So in the networking world, you have a transceiver attached to a switch or a router. I'm going to say router, not router, because I'm not in America anymore. You have a transceiver, and that transceiver has a single path, typically a single path. So let's talk about, I don't know, like traditional serial lines with a TX and an RX. And the impression that you have when you're on the net is like you have all this speed, and then you get this parallelism. But that's an illusion, because you get that from an outcome of having such a fast lane. And there, your brain is much, much, much slower than a number of simultaneous conversations happening over that single lane. And they're all multiplexed on and off that single lane. And in networking, you can call that SerDes, serialization, deserialization, whatever you want to call it. And I think people forget this, that with a single TCP connection on a fast network, you can pack a lot of stuff into the time domain for that particular bearer that's then connected across the net or in your data center or whatever. And then you go, but I'm going to have another connection. Oh, right. So now you've got 2 connections with 2 different trains of payloads multiplexed onto the same underlying network interface on the same underlying CPU through the same memory. You're like, it's fundamentally the same, but you're probably adding more work now by adding another connection. And for what gain? Now, I want to table the notion here of separation of concerns. So you might launch a Go routine with an anonymous handler for something. And at that point, you might go, you know what? I'm just going to give that its own connection. Its one job is to like suck the life out of, I don't know, a load of regional conversations that are going on. And that thing is going to launch itself. And it's also assigned it's alive as well. It's doing its thing. It's there. Microservices, if you've got verticalized microservices in the same binary, so that kind of a modular approach where you have one deployable binary, but then you've got different, instead of going through the code path, through the in-process code path, you're externalizing everything through NATS. Maybe single connection per separate unit of logic. Again, I'm spitballing here, right? I'm trying to grill both of your brains to kind of get pushback and reasons for anybody listening to this going, is that a good idea? Well, maybe.
Yeah, That's insane, Dave.
Yeah,
I'll settle for that. Thank you.
But yeah, I think that the takeaway, just use one connection unless you feel there's very good reason to. You want to solve some weird problems, because as I said, like those 10 million messages that you can publish, which is not reasonable amount for almost any real use case, they can go through one connection, and I don't think you can get more if you do over 2 with the same client. So it's like it's absolutely enough, and start with core NATS, start with single connection, And I think that this is something that is, as NATS have this, I call it three planes. Like there is a API plane, meaning core NATS, JetStream, blah, blah, blah. There is security, and different ways you can secure NATS. And then there is topologies. And it's so easy and so tempting to like, I will, starting with NATS today, JetStream over leaf nodes, clustered leaf nodes, with distributed or of callouts for security. And you're getting into all the complexity just immediately. While I think that if you understand that under the hood everything is PubSub and everything is really this, you can really just start simple, start with probably single server, just run it locally, run single server locally, run an app with one connection, do what you need to do, and make it use more features from their own, because it will be way, I think, smoother sail for you and way more fun. Because you are like, oh yeah, I can do this and this, but I'm missing this. And then looking through the docs, is there something that NATS can help me with? And the answer is, yeah, there is. And it solved my yet another problem. So it will be solving your problems as you use more topology features, more security features, and more features API features as you go, rather than you do deep dive into all the complexity immediately, and you don't feel they are solving problems. You feel there are so many ways to solve this one problem. So I think that's always starting with core NATS single connection and single server, because the beauty is that you can scale it really easily from core NAS to JetStream, from single server to cluster, from cluster to leaf nodes and edge devices, and from non-secured server to multi-tenancy with accounts.
Yeah, and kind of adding to that as well, like if kind of what you were setting up, David, is like if you have one app with multiple kind of function handlers, let's say you have 10, how often are they actually going to get requests? So if each of them is going to be getting a request like once a second or maybe every 10 seconds, do you really need multiple connections for that? I wouldn't think so. So also from the perspective of like research usage, and it's just not needed. You can actually use one connection. So
yeah, and let's face it, short small requests, 1 a second. It's the system's probably got no reason to exist. I think in the world of compute and time, it's like non-existent. It's such an infinitesimally small thing to be doing, and really when we're talking here overloading the TCP connections to the point where they're saturated, I think you're going to have network problems way before the NATS system has problems. I mean, I did a random test the other day. I stood up a small cluster on some bare metal in Germany, and then I decided to do a bench, and I forgot the client was not on. I thought I was SSH'd into one of the servers. I did it from home, and I'm like, man, the performance on this sucks. Turns out I just saturated 100 megabit uplink, and that's all I'd done. You just flatline. I'm like, I'm not expecting this level of crapness, and it turns out it was all me. I just completely messed up with it, and you forget sometimes just how performant this system is. It's incredibly performant, kind of amazing, really.
Yeah, likely, like you said, you're going to get into network latencies more quickly. It's just
in general to network problems, right? It's usually the first thing that's bottlenecked. And it's even harder in the cloud environment when the I/O is burstable quite often. So it looks fine for a few hours and then suddenly drops, and you're like, "Oh, NATS is not working."
Happened? What happened?
No, nothing happened. It's just it's just how it works.
It was Amazon.
Blame out. Yeah. So,
or DNS, maybe.
Oh yeah, or this.
Always blame DNS.
Cool stuff. Anyway, we are way over time. I want to say thank you for. I feel a bit strange saying this. Kicking season 3 off with episode 1 on getting the most of core NATS. We'll pretend that season 2 didn't exist. It was a great episode. Let's move on. Anyway, so season 1. Thank you very much, Maurice and Tomasz. Right, I'm going to start top down from my screen. So Tomasz, anything that you want to leave any listener with? Any remaining bit of wisdom you have left for a Friday?
I think I said so many, maybe it's Friday, so many times, just use one connection, use one server, just use PubSub, that I'm like, I reiterated it while I try to say that I don't want to reiterate right now. So I'll just, just
put the episode on replay and then 2x speed.
And listen to episode 2 because it'll be interesting.
Lovely. Forward thinking, bit of forward correction going on there. I think you're angry about me cutting you off on Orbit, but that's all right. You can call back on episode 2 and give me some, jip.
You
Maurice.
asked about the retry. You asked about
did.
it. I'm like, it's a trap.
You set him up for it.
Yeah,
it was.
I was set up for the trap.
I ambushed you.
Yeah.
And I'm reaping the rewards. What can I say? No, that's good. Maurice, have you got anything that you'd like to leave anybody with?
Yeah, also pretty much what I said earlier. Like, I myself started with using JetStream and then kind of being amazed at how reliable is this, and stepping back and actually starting to use core NATS. I think that's it's a really easy path to start with JetStream, and for me it was kind of refreshing to then look at NATS core and also build some things with it. So the request buddy is really interesting, but also I had this website where I also did communication of like pretty much kind of a Google Docs, like where people are looking and which page they are at. I just made that pretty much in a few hours with NATS and just with PubSub. And I'm like, I open the page and I request everyone that's on the page and they respond, and it's just really nice how fluid it can be. And yeah, definitely check it out.
Awesome stuff. And I guess from me, thank you for listening. I don't know, I got weirdly obsessed with trying to do as much in core NATS as absolutely possible. I just think it's magic, and I will ever be a supporter of this. So no, this is cool. So thank you, listeners, for listening to episode 1, season 3. I hope you've enjoyed this. We're probably way over the 25-30 minutes slot that we wanted to go for. Join us again for episode 2. We'll get Tomasz back, and probably not me next time. You get sick and tired of hearing my voice. We'll get somebody else to host, but we'll talk about Orbit and obviously collecting all of the, I guess, use case specific and client specific stuff, and how we can further improve your experience. So thanks again for listening to NATS FM. We're from Synadia, and we'll catch you next time around. Cheers.